Good morning, class. We're back at the final exam review, and we left off with number 25. So 25 says, a child's grandparents wish to purchase a bond fund that matures in 18 years to be used for her college education. The bond fund pays 6.8% interest compounded semi-annually. How much should they purchase so that the bond will be worth $100,000 at maturity? All right, so we know that we're compounding semi-annually, so we're going to use A is equal to P times 1 plus R over N to the NT power. All right, where A is the final amount, P is the starting amount, R is the interest rate expressed as a decimal. Both of these N's are the number of times compounded annually, and T is time in years. Right, so we want it to be worth $100,000 at the end. So that's actually my A. We want to know how much to invest. So that's my P. The interest rate is 6.8%, so 0.068. It's compounded semi-annually, that's 2 times a year, and it's mature in 18 years. All right, now, we're just trying to solve for P here. So all of this stuff, right, if you plugged it into a calculator, it would just be some number. So all I have to do is divide both sides by that stuff. And that will give me my P. So we just use our calculator. And we plug it in exactly like we see it there. So 100,000 divided by 1 plus 0.068 over 2, all raised to the 36th power. All right, when we do that, we get 30,009.63. That's it. Pretty straightforward. All right, 26. The bones of a prehistoric man found in the desert of New Mexico contain approximately 5% of the original amount of carbon-14. If the half-life of carbon-14 is 5,600 years, approximately how long ago did the man die? All right, so we're using our half-life formula here. So this is A is equal to P times 1/2 to the T over K power. All right, of course, this is our final amount, starting amount, time in years. K is the half-life of whatever element we're talking about. Now it says that 5% is left. So you can pick whatever you want to be your starting amount as long as your final amount is 5% of that. Well, the easiest number to deal with percentages is 100, right? So if my starting amount is 100, 5% of that is just 5 times 1/2 to the T, which is actually what we're trying to find, how long ago did the man die, over K, and it says the half-life of carbon-15 is 5,600 years. Okay, now, don't be that student that multiplies these first. Remember, order of operations say exponents have to be applied before multiplication. All right, so we're actually going to have to find a way to get this out of our exponent. Well, first I need to get rid of this 100. So I'm just going to divide both sides by 100. So I get 0.05 is equal to 1/2 to the T over 5,600. All right. Well, you can either use your definition of logarithm here, right? This is an exponential form. We could write it in logarithmic form. Or since the base is 1/2, you can really just take log base 1/2 of both sides. So if you have log base 1/2 of 0.05, the log base of 1/2 here will cancel this, and you're just left with t over 5600. Well, I'm trying to solve for t, so I multiply both sides by 5,600. And that will equal t. So we plug that into our calculator. 5,600 times log base 1/2 of 0.05, and we hit enter, and we get that t is equal to 24,202.797 years. Done. Right, so again, as long as you know your half-life formula, pretty straightforward. Number 27, the logistic growth model, P of t, is equal to 0.8 over 1 plus 1.67 e to the negative 0.16 t, represents the proportion of new computers sold that utilize the Microsoft Windows 2000 operating system. Let t equals 0 represent 2000, so t equals 0 represents 2000. T equals 1 represents 2001, etc. Right, what proportion of new computers sold in 2000 utilized Windows 2000? So, since we want to know the number of computers using 2000 in 2000, that just means t equals 0. So I just plug 0 into here. 0.8 over 1 plus 1.67 e to the negative 0.16 t. Well, sorry, we wouldn't put a t there. We'd actually plug 0 in. Of course, 0 times anything is 0. Anything to the 0th power is 1. 1.67 times 1 is 1. So this is 0.8 divided by 2.67. So that equals 0.2996, rounded to 3 decimal places, is 0.300, which essentially is 30%. All right, B. Determine the maximum proportion of new computers sold that will utilize Windows 2000. Well, in a logistic growth model, right, the number's going to keep going up until it kind of plateaus. All you have to do is plug in some giant number. It's really the limit as t goes to infinity, right, which is kind of the same thing as t equals 99999, right? Just plug in a really big number in for t here, right? Of course, you can just plug it into your calculator, but what's going to happen here is this number times a super huge number is going to be a really big negative number. Well, e to a really big negative number is going to be 1 over e to a really big number, which is essentially 0. So 1.67 times 0 is 0. 1 plus 0 is 1. 0.8 divided by 1 is 0.8, right, which is 80%. Like I said, you could just plug this in here into your calculator and call it a day. All right, C. When will 75% of new computers sold utilize Windows 2000? All right, well, we know that now P of t has to equal 75%, which is 0.75. All right, and this has to equal 0.8 over 1 plus 1.67 e to the negative 0.16 t. Now, normally, I would actually want you to do the math and do this, but this is a multiple choice test. We're not showing any work, right? So it's actually quite easy to just go ahead and use our calculator, all right? You can put this, just 0.75, into y1. You can put this into y2, and you can see where they intersect. Or you could subtract 0.75 from both sides and just find the 0. Either way, it's up to you. All right, so I'm going to go ahead here and say 0.75. Oops. All right, and then go here, and that is going to be 0.8 over 1 plus 1.67 times e to the negative 0.16 t, which in this case will be x. So now all we have to do is graph these things. All right. Clearly, we're going to have to mess with our window a little bit. So I will say 0 to maybe 50 with 5. All right, now we're doing percentages here, right? And it's really like, from 0 to 1. So we can really just say like -1 to 1. That should be substantial. There we go. So this is easy enough to find our intersection. All right, so our intersection is 20.130. So here, t is equal to 20.13, 130. All right, and it asked when, so this essentially is the year 2020, which, hey, just happened. Of course, no computer uses that software anymore, but who cares? Okay, so now we will look at 28. 28 says, convert 210 degrees to radians. All right, so I take 210 degrees to convert that to radians. I multiply that by pi over 180. I reduce. 21 over 18 is 7 over 6. So this is 7 pi over 6. 29 says convert 3 pi over 8 to degrees. So I multiply that by 180 over pi. So my pi's cancel. All right, this would reduce. Let's see, does 4 go into both of these? Yes, 4 would go in here 45 times. 4 would go in here 2. So 3 times 49 is 135 over 2. All right, which is going to be, 67.5? So 67.5 degrees. All right, 30. Find the exact value of each expression. And A says tangent of pi over 4 minus sine of pi over 6. From our unit circle, we know tangent of pi over 4 is 1. we know sine of pi over 6 is 1/2, so this just equals 1/2. All right, and B, sine of 50 degrees over cosine of 40 degrees. Well, one of our trig identities, the cofunction identities, says that sine of 90 minus theta equals cosine of theta. All right, so in this case, cosine of 40 degrees is equal to sine of 90 minus 40, which is just sine of 50. So since cosine of 40 and sine of 50 are equal to each other, these two things are the same. Anything divided by itself is just 1. (31) Find the exact value of each of the remaining trigonometric functions given. All right, so given that tangent of theta is equal to negative 2/3, and that theta is between pi over 2 and pi, which basically tells me I'm in the second quadrant. So this is my theta. Tangent is opposite over adjacent. Okay, now one of these has to be negative. Don't just assume that the 2 is negative. It's not, because this is going up from the origin, right? This is going to the left, so this is my negative. I need to find my missing side here, so a squared plus b squared is equal to c squared. So c is equal to the square root of 13. Remember, the hypotenuse is never negative, right? So now we can say, all right, well, sine of theta is opposite over hypotenuse, which is going to be 2 square roots of 13 over 13, which means that cosecant is going to be square root of 13 over 2. Cosine of theta is adjacent over hypotenuse, which is going to be negative 3 root 13 over 13. And secant, we just flip our original cosine here to get the square root of 13 over negative 3. We were given tangent, so the only other thing we would need to find is cotangent, and that's negative 3/2. Pretty straightforward. Done. All right, 34. Name the quadrant theta lies in. If cosine of theta is greater than 0, and tangent of theta is less than 0. All right, well, this is our all students take calculus. So here everything's positive. Well, we know tangent is not, so we can't be here. We know cosine is positive, so I have to be down here in quadrant 4. All right, 35. Now the current I in amps flowing through an alternating current circuit is T is equal to 220 times the sine of 30 pi t plus pi over 6 for t greater than or equal to 0. All right, A. What is the period? Well, we know period is equal to 2 pi divided by b. Right, my b here is 30 pi. So 2 pi divided by 30 pi, the pi's cancel. 2 over 30 reduces to 1 over 15. B. What is the amplitude? The amplitude, of course, is just the absolute value of A, which is 220. And C, what is the horizontal shift, which remember I call that the start, which is equal to C over B. So in this case, my C is negative pi over 6 divided by 30 pi. I'll think of that as over 1. I will do keep, change, flip. So the pi's will cancel. So this is equal to negative 1 over 180. Done. All right, 36. Says find the exact value of each expression. So what is the inverse sine of the square root of 2 over 2? Remember, for inverse sine, we just look at the right half of the unit circle and say, okay, where is sine square root of 2 over 2? That occurs at pi over 4. And that was part A. B says, what is the secant of the inverse tangent of 1 over the square root of 3? Okay, well here, this is when we say, okay, let U equal the inside stuff. And then we take the tangent of both sides, so we know tangent of U is equal to 1 over the square root of 3, which is also square root of 3 over 3. But we'll see if we need that. We probably still actually want this form. I'll show you why in a minute. All right, well, we know that we're dealing with inverse tangent, which is the right half of the unit circle. This is a positive value, which means we have to be in the first quadrant. All right, tangent is opposite over adjacent. And then a squared plus b squared equals c squared. So 1 plus 3 equals c squared. So this is going to be 2. So now basically we're looking for what is the secant of u. All right, well, secant of u is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so square root of 3 over 2. So secant is hypotenuse over adjacent, so 2 over root 3, which is equal to 2 square roots of 3 over 3. Done. All right, continuing on. Still on 36, but now on C. All right, we have the tangent of the inverse sine of negative 4/5. So again, we let u equal the inside piece. So sine of u is equal to negative 4/5. Inverse sine is also the right half of the unit circle. Because our value is negative, we know we have to be in the fourth quadrant. Sine is opposite over hypotenuse, right? And I know that both of these legs have to be negative because I'm in the fourth quadrant. This is a 3, 4, 5 right triangle. Of course, you could have just used the Pythagorean theorem to get that. Well, now I'm really just looking for tangent of u. Tangent is opposite over adjacent, so this would be 4/3. Done. D says sine of 70 degrees times the cosine of 40 degrees minus the cosine of 70 degrees times the sine of 40 degrees. Well, this is essentially our sine u, cosine u, minus cosine u, sine u, which is essentially equal to sine, I'm sorry, this is u and v, of course. All right, so this is sine of u minus v, which in this case is going to be the sine of 70 minus 40, which is equal to the sine of 30 degrees, which is simply 1/2. Done. All right, 37. If sine of alpha is equal to 4/5, and if you don't like Greek letters, don't worry about alpha and beta, just make them A and B, or $ and happy face. It doesn't really matter. All right, so if sine of alpha is equal to 4/5, all right, and alpha is between 0 and pi/2, and cosine of beta is equal to -5/13, and beta is between pi/2 and pi. All right, find each of the following. Okay, so first, what we're going to have to do is use this to get, the other pieces of alpha and beta. So, um, sine, cosine, tangent. Of course, looking at A, B, C, and D there, we don't have any tangents, so we're not actually going to have to worry about that. All right, so here I'm in the first quadrant. So this is my alpha. Sine is opposite over hypotenuse. This is a 3, 4, 5 again. So I know that cosine of alpha is going to be 3/5. I can do the same thing over here between pi/2 and pi. I know that I'm in the second quadrant. All right, and cosine is adjacent over hypotenuse. This is a 5, 12, 13. All right, so I know that sine of beta is going to be 12/13. So that's the preliminary work. Now we can actually do the stuff. All right, so A, sine of alpha plus beta is equal to sine of alpha times cosine of beta plus cosine of alpha sine of beta. All right, so sine of alpha is 4/5. Cosine of beta is -5/13. Plus cosine of alpha is 3/5. And sine of beta is 12/13. All you have to do is plug that right into your calculator, right? But this shouldn't be too hard. This is -20 plus 36, so that's 16 over 5 times 13 is 65. Of course, you can just plug that right into your calculator. Done. All right, B says to find cosine of alpha minus beta. Right, all of these formulas, these trigonometric things, are going to be on a formula sheet that you're going to be given, so don't worry about memorizing all of that. This will be cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. So again, you just plug in these numbers, right? So we are going to have cosine of alpha is 3/5 times cosine of beta is -5/13 plus sine of alpha is 4/5 times sine of beta is 12/13. All right, so again, our common denominator is going to be 65. So we're going to get -15 plus 48, so that's going to be 33. If I did that correctly in my head. All right, and finally, C says, what is the sine of 2 beta? All right, that is our double angle formula, all right, which is also on our formula sheet. All right, and sine of 2 beta on our formula sheet, it's sine of 2u. All right, that is simply 2, oops, a little sloppy, 2 sine beta cosine beta. All right, so 2 times the sine of beta is 12/13 times the cosine of beta is -5/13. So this is going to be -60 times 2 is -120 over 169. Again, you could just plug that right into your calculator. Now, letter D actually says cosine of alpha over 2. Okay, we never did the half angle formula, so you don't need to worry about that. That won't be on your exam. All right, 38. Solve each equation on the interval 0 to 2 pi. All right, so A says cosine of theta is equal to 1/2. Okay, well, on the unit circle, where is cosine of theta 1/2? That happens at pi over 3 and 5 pi over 3. All right, B says sine of 2 theta plus 1 is equal to 0. So sine of 2 theta is equal to -1. Remember, don't divide this by 2. We can't just magically do that. This isn't sine times 2 theta, all right? So we can't do that. We need to say, where is sine -1? And that occurs at 3 pi over 2. But now we're not saying theta equals that. We're saying 2 theta equals that. All right, so now we can go ahead and divide by 2, which is multiply by 1/2. So theta is equal to 3 pi over 4. We do have to be careful here. Our period is 2 pi divided by b, which is 2. So that's just pi, which means solutions repeat every pi. So if I add pi to this, 4 pi over 4, I would get 7 pi over 4. That's still between 0 and 2 pi. So those are our two solutions. 38C says 2 cosine squared theta plus cosine theta minus 1 is equal to 0. All right, well, we can factor this. If you don't like looking at the cosines, you can say 2u squared plus u minus 1. All right, so we get -2 a times c and 1. All right, so this is going to be, let's see, is this even factorable? So yeah, it's got to be, so 2 and -1. So this is going to be 2u plus 2, 2u minus 1. Take out the trash. This will be u plus 1 and 2u minus 1. Of course, we're not talking about u's, we're talking about cosines. So this will be cosine theta plus 1 times 2 cosine theta minus 1. Set these each equal to 0 and solve. Here we get cosine of theta is equal to -1. Here we get cosine of theta is equal to 1/2. Cosine of theta is -1 at pi, and cosine of theta is 1/2 at pi over 3 and 5 pi over 3. You'll also be given a unit circle for this final exam as well. All right. Done there. 39. It says use a calculator to evaluate the inverse cotangent of negative 1.3. All right. We do not have an inverse cotangent button on our calculator, so we need to take the reciprocal function, which is inverse tangent, and we need to take the reciprocal of the argument, so negative 1 over 1.3. All right. It doesn't say whether you should be in radians or degrees. Obviously, whatever the answer choices are in on a multiple choice test, if it's in radians, make sure your calculator is in radian mode. If it's in degrees, make sure your calculator is in degree mode. All right, so if we do the inverse tangent of negative 1 over 1.3, in degrees, that is roughly negative 37.569. All right, 40 says find the exact value of the 6 trigonometric functions of theta. All right, on the posted version, I don't think it had any numbers here. I believe I wrote them in when I made copies and handed them out to people, but I wrote 12 and 5 here, which means this is a 12, 5, 13 right triangle, so sine of theta. Okay, and it didn't tell us where theta is either. I forgot to put that in there. It doesn't matter which acute angle, right? Obviously, that would be in on the final, so I'll put it here. So sine of theta is 12/13, which means cosecant of theta is 13/12. Cosine of theta is 5/13, which means secant of theta is 13/5. And tangent of theta is 12/5, which means cotangent of theta is 5/12. Very straightforward, pretty easy. All right. 41 starts solving triangles. So I will go ahead and stop this video here since those usually take quite a bit of time. So I'll stop this video here and pick up the next video with those.